Hello, welcome everyone. In this video, I'm going to use the definition of derivative to derive the derivative of exponential function e to the x. So here we have this definition of the derivative. We have this limit as h goes to 0 of f of x plus h minus f of x over h is equal to the derivative of the function, and f of x here is going to be e to the x right here. Okay, so f of x plus h is going to be e to the x plus h. Okay, so now let's go ahead and use this function to find out what the derivative is going to be for e to the x using the definition of derivative theorem. So here I'm going to go ahead and make some substitution. So we have limit as h goes to 0 of f of x plus h minus f of x over h. And we already know that f of x is e to the x. We're using e to the x, and so f of x plus h is going to be e to the x plus h. So I'm going to go ahead and make a substitution for this into this definition of derivative. So let's go. So we get limit as h goes to 0. We know f of x plus h is e to the x plus h minus f of x is just e to the x over h. And now we can go ahead and simplify this. So e to the x plus h is going to be e to the x times e to the h minus e to the x divided by h. So limit as h goes to 0, we can factor out e to the x from here. So e to the x, and then we're left with e to the h minus 1 over h. Okay, and now we can take this e to the x out of the limit. So since there's no h involved there, so e to the x limit as h goes to 0 of e to the h minus 1 over h. Okay, now here we're gonna have this thing right here, this portion right here, limit as h goes to 0 of e to the h minus 1 over h. This is equal to 1. Okay, so if we do that, so e to the x and limit as h goes to 0 of e to the h minus 1 over h. This thing right here in the parentheses goes to 1. So your answer is just e to the x times 1, which is e to the x. Okay, so how does this thing equal to 1 as h goes to 0? So let's plug in h here. There's the rule that we use. It's called L'Hopital's rule. So in this one we are going to use, and the reason we're going to use it is I'm going to show you why. So e to the h is this. If you plug in 0 here, e to the 0 minus 1 over 0. So e to the 0 is just 1 minus 1 over 0. So we have 0 over 0. So when we have something, a situation like this, 0 over 0 or 1 over 0, this is called indeterminate form. So whenever we have this situation, then when we are taking the limit of some function, we can take the derivative of that function. So the limit of that function is going to be the same as the derivative of the function. So if we take the derivative of the function, so we're going to take the derivative of the upper part and the lower part. So I'm going to take the d over dh of e to the h minus 1 divided by d over dh of h. Okay, so we just learned that derivative of e to the x is just e to the x. So derivative of e to the h is going to be just e to the h, and we know that derivative of a constant is 0 divided by derivative of h is going to be 1 because we are taking the derivative with respect to h. So we are left with e to the h. And now if we plug in the h equals 0, e to the 0 is going to be 1. Okay, so that's how we get this whole portion e to the h minus 1 over h equals to 1 as h goes to 0. All right, so now we have already learned that the derivative, or we evaluated that the derivative of e to the x is equal to just e to the x. So now let's go ahead and we already know this one. So e to the x, the derivative of that d over dx is equal to just e to the x. Okay. There's another, since we're going to be using functions other than x, so there is a chain rule that we use. If we're taking the derivative d over dx of e to the u, so u is a function of x instead of just x, then this rule is going to be the derivative of e to the u is just e to the u times the derivative of this function u, which is du over dx. And now if u is equal to x, okay, if we make a substitution into this one, what do we get? So we get e to the x times d over dx of x. Okay, all I did is substituted this x for u in this expression, and if we simplify this, we get e to the x times d over dx, or the derivative of x is just 1, so we get e to the x. So this is the formula we're going to be using moving forward. Okay, when we take the derivative of e to the u with respect to x, it's going to be e to the u times du over dx. So let's go ahead and do this one. So here we are going to apply the same formula. The derivative d over dx of e to the u is going to be e to the u times du over dx. Okay, now here u is equal to 2x. Okay, so we can go ahead and plug this in. So we get d over dx of e to the 2x is going to be equal to e to the u, and u is 2x, times d over dx of u is 2x. So we get e to the 2x, and now we can take the derivative of this. We know that we can pull 2 out of the derivative because it's constant, so d over dx of x. So here we get e to the 2x times 2 times the derivative of x is going to be just 1. Okay, we're taking the d over dx, derivative of x with respect to x, so it's going to be 1. And that is equal to 2 times e to the 2x. So this is our final answer. Okay, hopefully this helps. If you like my video, please subscribe my channel. Thank you.